Hello! Welcome to Unit 4, Lesson 8, Multiplying in Scientific Notation. These are very basic steps that I wrote down that are also explained in your lesson. So, super basic. First, you're going to multiply the coefficients together. So those are those decimal values, okay? Multiply those together. Then multiply the powers of 10 by adding the exponents. Remember, when we multiply exponents and they have the same base, in this case 10, then you add the exponents. And then you just join the two results together. Now, if the coefficient results in a number greater than 10, we need to adjust. And so I do have a problem set up for that to go over. Okay? So, let's see here. Number 1. The weight of an ant averages about 3 times 10 to the negative 6 kilograms. There are about 1 times 10 to the 16th ants in the world. What is their approximate weight? So to find that, we're just going to, oops, I don't need my decimal, but we have 3 times 10 to the negative 6 times 1 times 10 to the 16th. So first thing I'm going to do is I'm going to multiply my coefficients. We've got 3 times 1, well, that's 3, right? And then I'm going to multiply my powers of 10, so I've got 10 to the negative 6 times 10 to the 16. Well, I can rewrite that as 10 to the negative 6 plus 16. Well, negative 6 plus 16 is 10 to the 10th. And then I can go ahead and combine them. So I've got 3 times 10 to the 10th, and this would be kilograms. That's how much, if we were to add the weight of all the ants in the world, that's how much they would weigh. Okay? So notice my coefficient, right, my decimal value here is between 1 and 10. I want that because that's what means that it's written in scientific notation correctly, and then it's multiplied by a power with an exponent, so I'm good to go in that respect, at least in the format. Okay? Number 2, the average human heart beats about 3.5 times 10 to the 7th times per year. The current population of Massachusetts is about 7 times 10 to the 6th people. That's a lot of people. How many heartbeats happen there per year? So again, to figure that out, we're going to multiply the heartbeats times the number of people. So we've got 3.5 times 10 to the 7th. We're multiplying that by 7 times 10 to the 6th. We could actually write it down here. We could say times 7 times 10 to the 6th, so we can like keep them aligned. Maybe that would help you. Well, we've got 3.5 times 7. You can do that multiplication out. I should have put my 7 right here. I guess I could do that because then I can just do the math right here. So when you're multiplying with decimals, you ignore it until the end. So I'm going to do 7 times 5. Well, that's 35, so drop my 5, carry my 3. 7 times 3 is 21, plus 3 is 24. Now I can go ahead and put my decimal into my answer. I have one decimal behind my, I have one number behind the decimal in my problem, so I should have one number behind my decimal in my answer. And then here, with these ones, 10 to the 7th plus 6th, right? Because we add our exponents. So that can be written as 10 to the 13th. So we've got 24.5 times 10 to the 13th. And you might think that you're done, but we want this number here, the coefficient, that has to be between 1 and 10 in order for it to actually be written in scientific notation. So to do that, I need to move my decimal point one spot to the left, giving me 2.45 times 10, and then since I moved it 1 to the left, I would have times 10 to the 14th. Okay, so that's how many heartbeats there are per year. Okay, I wouldn't even know how to say that number if it were written in standard form, right? There's a lot of place values there. All right, number 3. This is number 4 from your quick check. So make sure that you write this down. This one I kind of felt like they were trying to like throw you for a loop, right? They were almost like trying to trick you. So I wanted to make sure to talk about it. A sugar cube has a volume of about 4.9 milliliters. What is the total volume of 1.5 times 10 to the 6th sugar cubes? So we've got 4.9, that's our volume, and we're multiplying that times 1.5 times 10 to the 6th. Okay, so it's kind of like, well, what do we do here? How do we make sure that that is in scientific notation so that we can add these correctly, okay? And so since there isn't a times 10 to some power, we can actually just leave it. Or another way we could think about it is this is the same thing as 4.9 times 10 to the 0 power. Well, anything raised to the 0 power is 1, right? And 4.9 times 1 is just 4.9. So I could rewrite it like that so that then I can make sure that I'm completing my problem correctly. So in this case, we would do 4.9 times 1.5. So 4.9 times 1.5. I'm going to do that on my calculator. Is that okay? 4.9 times 1.5 gives me 7.35. And then if I take my powers of 10, well, I could rewrite that as 10 to the 0 plus 6, which is just 10 to the 6th. Okay? And then I can combine them. So I have 7.35 times 10 to the 6th, and milliliters. And with that, this is already between 1 and 10, so we don't need to alter our answer at all. And so we are all done. All right, I hope that helps. And reach out if you need more help, as always.